All right, today we're going to work on section 6.3, day 2, which is some more properties of trig. So again, this first slide is something that we've seen multiple times now, just refreshing your memory that sine is y over r, cosine of theta is x over r, tangent is y over x, and then we know the reciprocals. Cosecant is the reciprocal of sine, so that just flips it, r over y, r over x for secant, and then x over y for cotangent. And just like we've talked about before, it's always going to be cosine of an angle measure. So it's cosine of 20 degrees, cosine of pi over 4, etc. And that always has to be the ratio of the sides. So that's always going to be a fraction like root 2 over 2 or root 3 over 2, 1/2, etc. All right, so today we're going to continue kind of where we left off yesterday. First one is asking you to find cosecant and tangent given the information here. So the first thing we have to figure out is this is not a unit circle question. We've got to figure out where do we draw our triangle. So this first one is kind of weird because it gives me secant. Well, I know secant is just the reciprocal of cosine. So if secant of theta is 2, I also know that cosine, or negative 2, cosine is the reciprocal of that. And the reciprocal of that is just going to be negative 1/2. So I know that cosine is negative. So I'm going to get rid of the two quadrants where cosine is positive. So again, we have all students take classes. Everything's in positive in quadrant 1. Cosine is positive in quadrant 4 because that's what that C stands for classes, is the cosine and secant. And then tangent and sine for the other two. So we also know that tangent is bigger than 0, which means tangent is positive. Well, I know tangent can't be positive here because only sine and its reciprocal cosecant are positive. But I do know that tangent and cotangent are positive there. So that means my triangle's got to be in quadrant 3. So remember, when we draw our triangle, we start at the origin, we come out into quadrant 3, we hit the circle, and then we come perpendicular always to the x-axis. So there is my triangle. I'm going to go ahead and use cosine. Cosine, we could either call it the adjacent over the hypotenuse, or we can call it x over r. Either way. Well, we know the radius is always positive, so the radius has to be 2. And then the x value, because we're going to the left, that x value should be negative, and we're going to call that negative 1. So in this case, the negative goes with the 1 because we're going to the left, and then the 2 is the radius, which always has to be positive. We're almost done here, but we're missing a third side of our triangle. So to find that third side, we have to do Pythagorean theorem. So I know that negative 1 squared plus I'm just going to call it x squared, so we'll call this side x even though it's the y value, equals 2 squared. Negative 1 squared is 1, plus x squared equals 4. Move that 1 over. We get x squared equals 3, or technically x is plus or minus root 3. So what we need to do is we need to take a look at that triangle, and we've got to decide, is it a positive value or a negative value? Because I'm going down into quadrant 3, we know that that piece has to be negative. Anytime you go left or down, it's always going to be negative. So in this case, negative root 3 is the answer that makes sense there. All right, so all we have to do is find cosecant and tangent. So I know cosecant is the reciprocal of sine. Sine is y over r, so this is going to be r over the y value. I'm going to do it down here first. My radius is 2. My y value is this guy right here going down, so negative root 3. So I'm going to rationalize root 3 on top, root 3 on bottom. So I get negative root 3 over 2, or negative 2 root 3, and then root 3 times root 3 is root 9, which is 3. So my cosecant value is negative 2 root 3 all over 3. And again, because we're in quadrant 3, only tangent and cotangent should be positive, so that makes sense that this value is negative. All right, so let's take a look at tangent. Tangent, remember, is y over x. So my y value is negative root 3. My x value is negative 1. I know that 2 negatives is a positive, and it just gives me a positive root 3. And just like we talked about, if the triangle's in quadrant 3 or the angle's in quadrant 3, we know that the tangent value has to be positive. Could we have found sine, cotangent, and the others that we're missing? Absolutely. But in this case, I only asked you for 2. All right, so now we're going to talk about what quadrant does an angle lie in, right? Where does it terminate in? And how do we figure that out if it's not a unit circle value? And if it's maybe negative, maybe it's too big, too small, how do we figure out if it's not one of our unit circle values? So let's start with degrees because degrees is always easier. We know over here that this is 0. We know that this is 90. We know this is 180, 270, and then coming back around gives me a full 360. All right, so I want to figure out where negative 415 is. So we talked about coterminal angles, right? Coterminal angles terminate or end in the same spot. So the way that we find coterminal angles is by adding or subtracting 360 if it's in degrees, or adding and subtracting some form of 2 pi if it's in radians. All right, so the first thing I'm going to do is I'm going to take that negative 415 in my calculator. I'm going to add 360, and that gives me negative 55 degrees. Well, I don't like that because it's still negative, so I'm going to go ahead and I'm going to add another 360 again, and that gives me 305 degrees. Well, now this makes it pretty easy. If 270 is here and 360 is there, 305 has to be somewhere kind of in the middle. And again, I don't care where we put it, but we know it has to be in quadrant 4. Remember, we write quadrant 4 with an I and a V because V is 5, and basically that means take away 1. 5 take away 1 is 4, so it's in quadrant 4. All right, same idea for the next one, except for we are going to go ahead and do this one in radians. So instead of adding and subtracting 360, we're going to add and subtract some form of 2 pi. We did this the other day in class. Well, I know that my denominator has to be thirds. So I know 2 pi, if I double 3, that gives me 6 pi over 3. So what we need to do is we need to add 6 pi over 3, and we're going to actually have to do this a few times, because if I take negative 22 and I add 6, that gives me negative 16 pi over 3. If I add another 6 pi over 3, positive 6 pi over 3, that gives me negative 10 pi over 3. If I add another 6 pi over 3, that gives me negative 4 pi over 3. And if I add 6 pi over 3 again, that actually gives me 2 pi over 3. So if I keep adding 6 plus 6 plus 6 plus 6 a whole bunch of times, it ends up being like 24 total. And then take away that 22 pi over 3, that gives me 2. Now, you may remember that 2 pi over 3 is a unit circle value. You may get a value here that's not a unit circle value, and that's okay. So let's talk about how we can find that out if we forgot it was a unit circle value. So I know over here is 0. And I know over here is pi. But if I have a denominator of 3, I want to write pi as a fraction. So I'm going to call that 3/3, right? 3/3 is the same as 1. And then 2 pi, like we set up here, would be 6 pi over 3. So I know this whole circle has to start at 0, and one full circle around is 6 pi over 3. So a half circle is 3 pi over 3. Well, up top, we have to have this in thirds. Well, I know that's half of pi. Well, if pi is 3/3, that means this has to be 1.5, right? 3 cut in half. It's got to be half of that, or 1.5 thirds. Okay, and then the hardest one to figure out is the one down here, but it's actually not so bad. This is really 3 pi over 2, which is the same as 1.5 pi. So I know that 1 full pi is 3/3, and I know half a pi is 1.5 thirds. So if I take those two and I add them together, that gives me 4.5 pi over 3, or 4.5 thirds pi. All right, so again, we're trying to find the quadrant that this angle is located in. So I know if I start here at 0 and I rotate, well, there's 1.5. Well, I know 2 is more than 1.5, but less than 3. So 2 pi over 3 has to end in quadrant 2. So that angle terminates into quadrant 2. So we want to just keep adding 2 pi, keep adding 360, depending upon what units it's in, and then try to figure out where that angle is located. All right, so since degrees is a little bit easier and radians is a little bit harder, I'm going to do the same thing, but we're going to pick some that are not on the unit circle. So let's talk about 18 pi over 3. Okay, so first of all, we've got to figure out, is that between 2 pi? So between 0 and 2 pi. So one of the things I can do is I can take my calculator and I can do 18 divided by 13, which is 1.38 with some change at the end. So I know that's smaller than 2 pi. So in this case, this angle is not too big. Okay, so let's talk about labeling the circle. So if I start over here on the far right, that is 0 or 0 pi. And if I go over here to pi, I know if I use fractions, this has to be 1 pi. Since we're talking about a denominator of 13, that's going to be 13/13. Okay, so if this is 13 and I go another 13, that means 2 pi, like we've talked about before, has to be 26 pi over 13. All right, so now we got to figure out the other two missing pieces. So up at the top, I know that's pi cut in half. Well, 13 is not so nice to cut in half, but that's 6.5. If I take my calculator and divide it by 2, that's 6.5 thirteenths. And we just talked about how to find down here, that's 1.5 pi. So if I take 1 pi, which is 13, and 13 out of 13's pi, plus the 6.5 out of 13's pi, and I add those up, that gives me 19.5 thirteenths. And if you take your calculator and you take 19.5 and divide by 13, you'll see that you get 3/2 or 1.5. And again, that needs a pi there. So I've got to figure out where 18/13 is. So I start at 0 and I rotate. I have to go past 6. I have to go past 13. But since this one over here is 19, I know I've got to stop short of that. So in that case, this angle is in quadrant 3. It's more than 13, but it's smaller than 19.5. So 18 pi over 13 has to be in, or has to terminate in, quadrant 3. All right, last one is kind of a big one. It's negative 50 pi over 7. So let's go ahead and label that triangle. I'm going to slide that over just so I have some extra room. So if I start at 0, I'm in terms of sevenths. So this is going to be 7 pi over 7. I know a full circle of half is 7 and another half is 7. So a full circle would give me 14 pi over 7. Up top is a half pi. So if 1 pi is 7/7, if I cut that in half, that means up top has to be 3.5 pi over 7. And then down on the bottom, remember we get that from taking the top 1/2 plus 1, gives me the 1 1/2 down there. So 3.5 plus 7 gives me 10.5 pi over 7 on the bottom. All right, so obviously negative 50 is way too small. So we're going to find that coterminal angle. So we're going to add, in this case, out of 7, 2 pi would be 14 pi over 7, which we found over there. So we're going to add 14 pi over 7 a few times. So if I take negative 50 and I add 14 pi over 7, that gives me negative 36 pi over 7. If I add another 14, so if I add another 14 pi over 7, that gives me negative 22 pi over 7. If I add another 14 pi over 7, that gives me negative 8 pi over 7. And I'm thinking you can tell that we're almost there. If I add another 14 pi over 7, that gives me 6 pi over 7. So again, what we have to do is we have to locate where is 6 pi over 7. So if I start at 0, I know it's past 3.5, but it's not quite to 7. So I know that 6 pi over 7 has to be in quadrant 2. I think this is the easiest way to do it. Could you rotate counterclockwise from, clockwise from 0 and rotate down? You could find the negatives that way as well. But I think changing it to a positive angle between 0 and 2 pi makes it a little bit easier to find. All right, another thing we're going to talk about is some more properties which are called the negative angle properties. Okay, so they're also sometimes referred to as the even-odd properties. And again, that has to do with even and odd functions like we studied in chapter 1. All right, so let's take a look at the first property. The first property says sine of negative theta is the same as sine of positive theta. All right, so let's say theta is 30 degrees. So if I rotate to 30 degrees, I know my ordered pair is root 3 over 2, comma a half. And if I rotate down negative, so to negative 30 degrees, I know that ordered pair is still root 3 over 2, but the y value this time has to be negative. All right, since sine is the y value, if we compare the y values of positive 30 and negative 30, what do you notice? Well, they're the same number, except for sine of negative theta is just negative 30 is just the opposite of sine of positive 30. And that's all that property is saying. It says that sine of negative theta is the opposite of sine of theta. Okay, now we can do the exact same thing for cosine. So if I rotate to 30 degrees, that's root 3 over 2 comma 1/2. And if I rotate to negative 30 degrees, that's still root 3 over 2, and it's negative 1/2. So cosine we know is our x values. So if I rotate to my x values, I notice that here it's root 3 over 2, and here it's root 3 over 2. So what do we know about these two values? We know that those two values are equal. So cosine of negative some angle, in this case 30 degrees, is the exact same as cosine of positive 30 degrees. And this works for 150 degrees, it works for 300 degrees, and then negative 300 degrees. So all these hold true for any theta or any angle measure that you would like to plug in. All right, so let's take a look at tangent. So tangent, we'll just use that 30 degrees again. So I've got root 3 over 2 comma 1/2, and down here at negative 30, it's still root 3 over 2 comma negative 1/2. Now remember, tangent is y over x. So if I take a look here at 30 degrees, I'm going to take the y value, which is 1/2, and I'm going to divide by root 3 over 2. All right, that's going to give me a positive angle. Now, if I do the same thing, or a positive value, if I do the same thing down here for negative 30 degrees, I'm going to take negative 1/2 divided by root 3 over 2. Now, notice if I divide these two values, I'm going to get the exact same answer. I'm going to end up getting root 3 over 3 if you wanted to do the math. But notice that one of them is going to be positive and then the other is going to be negative. So just like sine, what happens when we do tangent is tangent of negative angle is also opposite of tangent of the positive angle, because you're in quadrant 1 and quadrant 4. In quadrant 1, tangent is positive because both of these values are positive, and then in quadrant 4, one of the values is negative, so tangent has to be the opposite. Okay, now the nice thing is if it works for sine, it also works for cosecant, right? Because we're still talking about those same fractions. I'm just going to do the reciprocal, so this would be positive 2, and this would be negative 2. So the numbers are the same, the only difference is the signs. Same thing works for secant and for cotangent. Okay, so what we're going to do is we're going to use the negative angle identities or negative angle properties to find the exact values of these angles. Now, could you add 300 or 360 degrees here and find a coterminal angle? Absolutely. That is one way to do it that you still could do. But because I'm specifically asking you to use the negative angle identities or negative angle properties, let's go ahead and do that. Okay, so the first one we're going to look at is sine. So sine of negative, in this case, negative 60, is going to be equal to the sine of 60 times that negative 1 in front. So I know this is equal to negative, sine of 60 degrees. So if we go ahead to our unit circle, 60 degrees is up here. My ordered pair is root 3 over, or 1/2 comma root 3 over 2. We know that sine is my y value. So my solution to this is just going to be the opposite of that y value of sine of 60. So sine of 60 is root 3 over 2, but then we've got to throw that negative sign in front. All right, so secant. Secant is the reciprocal of cosine. So in this situation, this is going to be the same as secant of positive 45 degrees. So negative 45 and positive 45 degrees when we're talking about the x value, right? The x value here and the x value here are going to be the same. So I know that secant of negative 45 is the same as secant of positive 45. So if I go to 45 degrees, there's root 2 over 2, comma root 2 over 2. Fix that real quick. Root 2 over 2. So secant is the reciprocal of cosine. Cosine is my x value. So I just have to really take that and flip it. So I get 2 on top and root 2 on the bottom. You also could do 1 over root 2 over 2, which would then turn into that, which we've talked about before. And then if I go to rationalize, I get root 2 on top, root 2 on bottom. which gives me 2 root 2 over, in this case, 2, and then my 2's reduce, so I end up with just positive root 2. All right, last one is tangent of negative 3 pi over 4, so now we're in radians. Okay, so if we remember to the tangent properties say that the angles aren't the same, they're the opposite. So I know that tangent of negative 3 pi over 4 is going to be the same as negative 1 times the tangent of positive 3 pi over 4. So again, we've got to know our unit circle. 3 pi over 4 is over here in quadrant 2, and it's a pi over 4, so I know my ordered pair here is negative root 2 over 2, and then positive root 2 over 2. Well, we know tangent is y over x. So if I take my y value, which is positive root 2 over 2, and divide by negative root 2 over 2, well, the nice thing here is these values are the same. So when I divide, I get a 1. But in this case, it's going to be a negative 1. Okay, but the negative angle identity says I take the tangent of 3 pi over 4, which in this case is negative 1, and I got to multiply it by a negative sign. So I'm really doing negative 1, which makes that positive 1. So tangent of negative 3 pi over 4 is the same as positive 1 because I have to do the opposite of the tangent value at 3 pi over 4. All right, so the last thing we're going to take a look at is what we call the Pythagorean identities. So these all stem from the Pythagorean theorem, which is a squared plus b squared equals c squared. All right, so one of the things that we talked about a little bit in the beginning of this chapter is if I have a circle whose center is 0, 0, and the radius is 1, the generic form of a circle centered at 0, 0 is x squared plus y squared equals r squared. If it's not centered at 0, it's x minus h squared, y minus k squared equals r squared. The only difference here is we would have numbers like minus 2 and plus 3 to shift that circle left, up, down, right, etc. So because this unit circle has a center of 0, 0, the h and the k value are 0, so we end up with the equation x squared plus y squared equals 1 because the radius is 1 and 1 squared gives me 1. All right, so one of the things we can do is we can go ahead and take this equation right here, x squared plus y squared equals 1, and we can think about some of the properties of our unit circle. Well, our unit circle, the x represents cosine of an angle, and then y represents sine of the angle. So we can substitute in cosine for x and sine of theta for y. So one of the properties or one of the Pythagorean identities is that cosine squared plus sine squared is equal to 1, right? If I substitute cosine in for x and sine for y and square it, I get cosine squared plus sine squared equals 1. This is going to become something that you memorize just because we're going to use it enough. But there are two other versions of this same equation. So if I take that cosine theta or cosine squared theta plus sine squared theta and set it equal to 1, I want to see if I can make any modifications of this. Well, one of the things I could do is if I multiply or divide both sides by the same thing, that's a legal math move. So what I'm going to do is I'm going to divide both sides, or in this case, I'm going to divide every single term by cosine squared. Okay, so what happens here? Cosine squared divided by cosine squared becomes 1. Sine squared over cosine squared, where I know that sine over cosine is tangent, so if they're both squared, that becomes tangent squared theta. And then I know 1 over cosine, that's just the reciprocal of cosine, which is secant, in this case, squared. So this right here is just a modification of the original Pythagorean identity. All right, so you're probably guessing that we can do the same thing with that cosine squared plus sine squared equals 1. So we're going back to the original. And this time, instead of dividing by cosine squared, we can divide by sine squared. So let's divide both sides or divide every term by sine squared. And we get our last Pythagorean identity. If I get cosine over sine, that's cotangent, but because it's squared, we get cotangent squared. Sine squared over sine squared is 1. And then the last, the reciprocal of sine squared is, whoops, that should be an equal sign in the middle, is equal to cosecant squared of theta. And there is our last Pythagorean identity. Now, we'll do more with these Pythagorean identities as we get further into chapter 7. But you can take these identities and you could move them around. So if I take cosine squared plus sine squared equals 1, I could move the sine squared over to the other side. So I know that cosine squared is equal to 1 minus sine squared. So we're going to talk more about that later. What I want to focus on today is just the fact that there are 3 different Pythagorean identities, and we are going to be able to use them. So again, the thetas have to be the same. So if this is 30 degrees, this has to be 30 degrees in order for this identity to work. Or if this is 3 pi over 4, that has to be 3 pi over 4 in order for those identities to hold true. So let's take a look at this one right here. We're just going to use these expressions and try to modify them into one of the Pythagorean identities. So the first thing, I can't really do anything with sine squared, so I'm going to leave it as sine squared of pi over 12. But secant, I know that secant is the reciprocal of cosine. So this right here is 1 over cosine squared of pi over 12. So if I take 1 and I divide it by 1 over cosine squared of pi over 12, that's the same as 1 times the reciprocal, so 1 times cosine squared of pi over 12. So this part right here just becomes cosine squared of pi over 12. There was a plus sign in the middle, so it says plus, plus cosine squared of pi over 12. Now, if we go back to our identities, it says cosine squared plus sine squared right up here in that top one. Well, that's the same as sine squared plus cosine squared. So because these angles are exactly the same, if I take cosine squared and sine squared, and if I add those together, I end up with 1. So that whole thing simplifies to just 1. All right, if I take a look at this one, I notice that, hey, these are different. One's a positive 321 and one's a negative 321, and that's okay. But we need to make them the same. Okay, now, one of the things you might think about doing is adding 360. So the downside, if I take negative 321 and I add 360, that turns into secant squared of 39 degrees. And that doesn't help me because those two angles are the same. So whereas that might have been your first thought, it's not a bad thought, but it doesn't help us in the situation that it doesn't turn these angles into the same angle measure. Okay, so I want to go back, and I'm going to scroll back here to our negative angle identities. Okay, so I know that secant of a negative angle is the same as secant of the positive angle. So if I go back to this problem down here, I know that secant of a negative angle is the same as secant, and it's going to be the same for squared, secant squared of the positive angle. All right, so that's just using that negative angle identity. It has nothing to do with squaring an angle and making it a positive. It has to do with the fact that I know secant of negative 321 and secant of positive 321 are the exact same. And if I square them, they're going to be the same as well. So this becomes tangent squared of 321 minus, and then this becomes positive secant squared of 321. So that negative sign still stays, or that minus sign still stays minus in the middle. All right, so again, let's go back to our Pythagorean identity because we do have one up here that has tangent squared and secant squared. All right, so I have to modify that a little bit like I was talking about before. So if I have 1 plus tangent squared of an angle, and that's equal to, equal to secant of the squared of the angle. And if you go back to our problem, we have tangent squared minus secant squared. So we want to try to manipulate this identity to give us tangent squared minus secant squared. So what we're going to do is we're going to subtract that secant squared over. So now I have tangent squared minus secant squared, but that means I need to move this 1 to the other side. So I know that tangent squared of an angle minus secant squared of an angle has to equal, because those go away, has to equal -1. So as long as those angles match, it's going to be equal to -1. And because we use the negative angle identity to make them match, I know my final answer is -1. All right, your homework is worksheet 6.3, day 2. It's posted on Schoology. Your answers are on Schoology as well. But again, please do not just copy my answers. Do the problem, check the answer, and then we will discuss it when we come back to class on Wednesday. Thanks.